Hello, I'm doing this question. It's question 8 in October 2018 paper in Mechanics 1 that has a very common mistake about friction and the direction of the friction and the magnitude of the friction. You have a rod plane, so you will have friction, inclined 30 degrees with the horizontal, and then you have a particle P. You know the mass is held at rest on the plane by a horizontal force of magnitude 5 newtons. So this is holding our particle here at rest because otherwise it will probably slip down. The force acts in a vertical plane. The particle is at the point of moving, so this line is important, at the point of moving, because that means that our friction is going to be maximum. So when the particle or the object is moving or at the point of moving, we can assume that the friction is maximum. So we can use the formula that we know, and I'm going to write in a minute. Find the magnitude of the normal reaction of the plane on P. So first of all, I'm going to draw all the forces that we have here. So we have the weight of the particle pointing always down, and this is going to be 0.5 g because the mass is 0.5 g. Then I have a normal reaction, always perpendicular to the plane, so this way, perpendicular, I'm going to call it R. Then we have our 5 newtons, it's already drawn, and then we have friction. This particle is not moving, but we are trying to push it up the hill. So the friction is going to go against that attempt of moving. So imagine this was super slippery, we would be able to move it up. So the friction is going to go down, always against the motion or the tendency of the motion if we don't have motion. So I'm going to call it FR from friction. So these are our forces. Remember, when we work in inclined planes, usually we work parallel and perpendicular to the slope. So we are going to resolve forces in those two directions, parallel and perpendicular to the slope. So we have this direction parallel to the slope, this direction perpendicular to the slope. And any force that is not in those directions, we can resolve them in those directions. So in this case, I have the weight that is in a different direction. So I'm going to find the components in that perpendicular and parallel to the slope. So I have this component here. This angle, remember, is the same than this one, so it's 30, and this is the adjacent to the angle, so this is going to be 0.5 g cos, because it's the adjacent of 30. Then I have another component, in this case parallel to the slope, which is this one, and it's going to be the opposite, so 0.5 g sine of 30. So this is with this force, with the weight. But again, we have another force, this one, the 5 newtons, that is in a different direction of parallel and perpendicular to the slope. So I'm going to find the components. I have one component, and this time is pointing down, because my this is pointing this way, so this one will be pointing down, and this angle here is 30 as well, because they are alternate angles. So this is 30. This line here is the same that this line, this length, right? This is the opposite to the angle, so this is going to be sine. So that means this is 5 newtons sine of 30. And then the other component will be here. I'm pointing towards the particle, so I have many lines now, and it becomes a bit confusing, but this force is going to be 5, and in this case cos of 30. So I have 5 cos of 30, and I'm going to put the friction a bit closer to the arrow so we don't get confused. Friction. Yeah, so lots of arrows and forces. I hope the sketch is clear. The first thing they ask is find the magnitude of the normal reaction of the plane on P. Normal reaction, so they are asking us about this one. So we are going to resolve forces perpendicular to the slope. We have one force pointing up, which is this one, and then I have two forces pointing down, this red and this red. So the two pointing down are going to be the same that the one pointing up. because I don't have acceleration in this direction, right? So forces will be, so for A, if I apply forces is mass acceleration, and I know the acceleration is 0, if I resolve perpendicular to the slope, I have that the normal reaction, which is pointing in one direction, is going to be the sum of the other two pointing in the other direction, which is 5 sine of 30, 0.5 g cos of 30. So 5 sine of 30 plus 0.5 g cos of 30. If we do that with the calculator, because we know all the values, this is going to be 7.74 newtons. So far, no problems with this part of the question. Then, for B, they ask, find the coefficient of friction between P and the plane. We said that the particle is on the point of moving, no? It says here, the particle is on the point of moving up the plane. So that means that our friction will be maximum and is going to be mu coefficient of friction times normal reaction. They are asking us this coefficient. We know this reaction because we just found it. So we need to find what is this friction, maximum friction. So we are going to resolve forces parallel to the slope. That is where our friction is acting. So if we resolve forces in that direction, again I don't have acceleration. So the force pointing down, this friction down, together with this component of the weight that is again pointing down, so this one is going to be the same together than this one pointing up. So I have two pointing down, the blue and the small red, and then one pointing up. So I have that friction plus 0g, so friction plus 0.5 g sine of 30 is going to be the one pointing up, that is 5 cos of 30. And from here, we get that the friction, just substituting, is 188 newtons. So what I'm going to do is going with this friction here. So I'm going to go with, this normal reaction here and this friction here, and I'm going to find mu. So mu will be, coefficient of friction will be the maximum friction divided by r, so 1.88 divided by 674. This is going to be 0.28, and this is my coefficient of friction. Then next part of the question is where the problems come. The force of magnitude 5 newtons is now removed, and P accelerates from rest down the plane. So we are holding the particle in place, so we remove this force, and then the particle slips down. Find the speed of P after it has traveled 3 meters down the plane. Whenever in a forces question they ask you about distances or times or velocities, that means we are going to use Suvat equations. And for using Suvat equations, we need to find the acceleration. And that's where the forces come. So we are going to use forces again to find acceleration, and then Suvat to find speed. We need to find acceleration down the plane. So I'm going to do a new sketch because my forces are going to be slightly different now. So I have my plane again, and I have my particle, and the forces that I have acting on the particle will be the weight that hasn't changed because the mass is the same, then the normal reaction pointing up, and I have friction. The friction before, it was pointing down because I was trying to move the particle up. Now the particle is moving down, and this is a mistake, not changing the direction of the force. So be careful with this one. This is mistake number 1 in this question. Friction in this case has changed from pointing down to now pointing up because my particle is moving down with an acceleration, and the friction goes against the acceleration. And mistake number 2 is that this friction is not the value that we found here. So this friction, the value is not 188, right? Because friction is coefficient of friction times by normal reaction. Coefficient of friction hasn't changed because it's the same surface and the same particle, and it depends only on the roughness of them. But the normal reaction has changed, and it has changed because I don't have this force anymore. Yeah. So when I found the normal reaction before, I was including this value here, and I don't need to include it now, right? So I will have a different normal reaction. So this R will be different, and this friction will be different, and I will need to find it first. Yeah. I don't have any more forces, so I'm going to find the components of the weight in my two directions. So this one is going to be this was 30 degrees, this was 30 degrees again, is 0.5 g cos of 30, and this one is going to be 0.5 g sine of 30. So what I'm going to do is to find the acceleration. If I want to find the acceleration, I will need to resolve forces parallel to the slope. And my resultant force is going to be mass acceleration. The acceleration is what I need to find. So if it's moving down, I will have 0.5 g sine of 30. I know everything so far, minus the new friction. But I don't know the new friction, so I will need to find it. The mass is 0.5 and the acceleration is what I need. So what I'm going to do to find friction is to find the new normal reaction and multiply by coefficient of friction. So my new friction will be coefficient of friction times by new reaction. And to find the new reaction, I'm going to work perpendicular to the slope. I have only two forces now, so it's much simpler than before. I have reaction pointing up, this force pointing down, so they will be equal because I don't have acceleration in that direction. So, sorry, my reaction is going to be 0.5 g cos of 30. I don't have the value, but I'm going to do it in a minute. So I have 0.5 times 9.8 cos of 30 is going to be 4.24 newtons. That means that my new friction, and I'm going to go with this value here, is going to be 0.8, that is the coefficient of friction that we found before, 4.24, and this is going to be 1.188 newtons. That's my new friction. So if I come back here, I have that 0.5 g sine of 30 minus the new friction minus 1.188 newtons is going to be 0.5a, and from here, if I solve for a, I have that acceleration is 2.52 meters second squared down the hill. I have my acceleration, so I'm going to use SUVAT to find the velocity at the end, because that's what they ask. They say find the speed of p. In this case, speed and velocity is the same after it has traveled 3 meters, so that's the displacement down the plane. So we can write what we know. Displacement is going to be 3 meters. Initial velocity is 0 because it starts from rest. Final velocity is what they ask. The acceleration is 2.52, and we don't need the time, and we don't know it. So I'm going to look for an equation, a SUVAT equation without t, right? So from my 5 SUVAT equation, one without t. That is this one. V squared is u squared plus 2as. So v squared is what I'm trying to find. U is 0, so the first term is 0, and then I have 2 times 2.5 times s, which is 3. I get the positive value because I get one positive, one negative, and this is 3.9 meters second, which is what they ask. And this is not an uncommon question, so you are mixing forces and SUVAT equations the minute that you have your acceleration, right? So again, the common mistake is when you remove a force, don't change the direction, or at least don't check, because it could be that it doesn't change. But you have to check if the direction of the friction changed. Before, the particle was trying to move up, so the friction was down. Now the particle is slipping down, the friction goes up. And this is different because the minute that you remove a force or add a force, this normal reaction changes. And if it changes, friction changes, right? Which is not the case in all the questions. So sometimes you don't have any other forces than the friction, the normal reaction, and the weight, and then the friction will stay the same value. But if you remove or add a force, the friction will change. That's all for this exam question. Hello! If you like the video, I have a free last-minute revision course the week before your exams. The link is in the description below. I'm working with international levels for Edexcel, but if you are an UK student, you will find this very helpful as well because the questions are identical, you just have less topics. I have other courses through the year, they are all in my website and the link is as well in the description below. I would love to help you.